to statistics class. We were discussing about interpolation and extrapolation, where we have discussed binomial expansion method, and we have also solved few problems under binomial expansion method. In this class, we are going to study the second method of interpolation and extrapolation, that is Newton's advancing difference method. This is Newton's method of interpolation. How to interpolate the values of y when under Newton's advancing difference method. See, in binomial expansion method, two conditions are to be fulfilled. First one is the values of x, that is independent variable, should have a common difference. Likewise, the same condition applies here also, that is in Newton's advancing difference method, the values of independent variable should have an equal difference. That is the first condition. And in binomial expansion method, the second condition was the value of x for which the value of y is to be estimated should be one of the value of x. But here, in this method, that condition need not be fulfilled. We can even interpolate the value of y when value of x is not one of the value of x. That's why this Newton's advancing difference method. For example, see, we will consider x values as 5, 10, 15, 20, 25. Next, values of y 3, 5, 7, 8, 10. Like this. Now, you can interpolate the value of y when x is equal to 23. See, this 23 is not one of the value of x. First condition is independent variable should have a common difference. Here independent variable is x. See, this values of x has a common difference of 5. Next, this value of x, that is 23, is not one of the value of x for which y is to be estimated. See, in this 23 is not given. When it is not given, that time also we can interpolate the value of y. We cannot interpolate under binomial expansion method. At this time, we have to interpolate the value of y by applying Newton's advancing difference method. Now we will see how to find out or how to interpolate the value. So there is a formula. Newton's method has formula. Newton's formula for interpolation is Newton's formula for interpolation is yx, that is which value I have to interpolate, that value yx is equal to y0 plus x first order leading difference. First order leading difference. First leading difference is denoted by delta 0 raised to 1. Next, plus x into x minus 1 divided by 2 factorial into second leading difference plus x into x minus 1 into x minus 2 divided by, after 2 factorial we are going to take it as 3 factorial, third leading difference plus x into x minus 1 x minus 2 into x minus 3 divided by 4 factorial, fourth leading difference plus so on up to n values of y, known values of y. How many values of y is known? Depending on that, this formula will be derived. See, yx is equal to y0 plus x first leading difference, that is delta 0 raised to 1 plus x into x minus 1 divided by 2 factorial, second leading difference plus x into x minus 1 into x minus 2 divided by 3 factorial, third leading difference plus x into x minus 1 x minus 2 x minus 3 divided by 4 factorial and fourth into fourth leading difference, and so on. It goes on continuing up to n known values of y. So this is Newton's formula for interpolation. So y naught is the initial value adjoining values of x. Two adjoining values of x. Like this, you can estimate the value of y. Value of x. X can be calculated with the formula x is equal to value of x to be interpolated minus the value of x at the origin divided by the difference between the two adjoining values of x. This is the formula to find out the value of x. Now, how to find out the value of x for time series data? The only difference is in time series data, year or date will be given. So, x is equal to, I'll write it here. X is equal to the year of interpolation, minus the year of origin divided by difference between two adjoining years. The difference between two adjoining years. So when time series data is given, that time x is equal to the year of interpolation minus the year of origin divided by the difference between two adjoining years. Now, how to find out this leading difference? Here in this formula, we have calculated what is x. Then you can easily calculate x minus 1, x minus 2, x minus 3. Now, how to find out this leading differences? Leading differences can be obtained with the help of table. So the table is leading difference table. The leading difference table is prepared as follows. Leading difference table. Leading difference table. First column is x. Second column will be y. Next column is leading difference. Leading difference. In that, up to known values of y we are going to write. That is first difference. First difference is written as delta raised to 1. Next, second difference. Second difference is denoted by delta raised to 2. Next, third difference. That is delta raised to 3. Lastly, next fourth difference. Up to known values of y, you have to find out the leading difference. Fourth difference. It is denoted by delta raised to 4. So this is the leading difference table column. These are the column heading. Now we will write the values of x given, that is x0, x1. Leave one line in between because you have to find out the leading differences. So x0, next x1, x2, x3, x4. Now y0, leave one line y1, again y2, y3 and y4. line which you have left there, you are going to write y1 minus y0 is equal to delta 0 raised to 1, first order. Next, y2 minus y1, in this case y2 minus y1 is equal to delta 1 and 1. Next, y3 minus y2, this is delta 2 raised to 1. Lastly, y4 minus y3, in this case y4 minus y3 is equal to delta 3 raised to 1. Next, here second difference will be calculated delta, in this space delta 1 raised to 1 minus delta 0 raised to 1 is equal to delta 0 raised to 2. Next, delta 2 raised to 1 minus delta 1 raised to 1 is equal to delta 1 raised to 2. Then these two values, delta 3 raised to 1 minus delta 2 raised to 1 is equal to delta 1 raised to 2 raised to 2. After this, third difference, these two values we are going to deduct and write it in middle. That is delta 1 raised to 2 minus delta 0 raised to 2 is equal to delta 0 raised to 3. Is third difference. Next, delta 2 raised to 2 minus delta 1 raised to 2 is equal to delta 1 raised to 3. Lastly, fourth difference will be deducting these two values. Delta 1 raised to 3 minus delta 0 raised to 3 is equal to delta 0 raised to 4. So like this, we are going to prepare a leading difference table in order to find out the first leading difference, second leading difference and third leading difference up to known values of y. So like this, with the help of this table, by substituting the values from this table to the formula, you can obtain the value of y which is to be interpolated. So we will solve one problem that I will get a clear idea how to interpolate the value of y under Newton's advancing difference method. So the problem is, from the following data, interpolate the sales for the year, the sales for the year 1998, and the information given are year, next sales in units. These are the two informations given. Year starting from 1996, 2000, next it is 2004, 2008 and 2012. And sales values are 47, next it is 84, 105, 111 and 140. So this is the value, these are the values given, and we are asked to interpolate the sales for the year 1998. When this kind of question is asked, here it is not clearly stated which method to follow, whether you are going to apply binomial expansion method or Newton's advancing difference method. See, first of all we have to see, here x is 1998, we have to interpolate the value of y when x is equal to 1998. See, 1998 is not one of the value of x. 1998 is not given in the the solution, let x and y be year and sales. Year and sales. Next, since the value to be interpolated, value to be estimated is not one of the value, not one of the value of X series. So apply Newton's method to estimate the value at x is equal to 1998. We are asked to interpolate the value of y when x is equal to 1998. Since now we have to see how many values of y is known. 1, 2, 3, 4 and 5. 5 values of y is known. Therefore, since there are 5 known values of y, prepare leading difference table as below. Prepare leading difference table. Leading difference table as below. So now we will prepare first leading difference table. Since 5 values are known, we are going to prepare leading difference table up to 5 known values of y. So leading difference table will be, first of all, you are going to write the values of x. Next column, we are going to write the values of y. So values of x. Next it will be leading differences. Leading differences. Leading differences. Leading differences will be up to 4. Delta raised to 1. Next, delta raised to 2, delta raised to 3, next delta raised to 4. So up to 4. Now we will write the values of x as given in the question. Starting from 1996, leave one line, next it is 2000, again leave the line, 2004, next 2008, and lastly 2012. Now we will write the values of y. Values of y are 47, next it is 84, 105, 111 and 114. Now we will mark values of y. y0, this is y1, y2, y3 and y4. Now we will find out the leading differences. I have told you just now how to prepare the leading difference table. We are going to deduct the values and write it in the middle space, whatever we have left. So this is y1 minus y0. y1 is 84 minus 47. 84 minus 47 is 37. This is nothing but delta 0 raised to 1, 37. Next, likewise 105 minus 84. 105 minus 84. Answer is 21. This is delta 1 raised to 1. Next, 111 minus 105 is equal to 6. This is delta 2 raised to 1. Next, 114 minus 3, minus into minus plus 15. So greater number sign is plus, minus into plus minus. You have to deduct 15 minus 3, it is 12. So it is here, it will be plus 12, delta 1 raised to 3. Next you want fourth leading difference, that is 12 minus 1. 12 minus 1 is 11, delta 0 raised to 4. This is the leading difference table. Like this you are going to prepare the leading difference table in order to solve, in order to interpolate the value of y under Newton's advancing difference method. After this, see what we are going to do is the first differences in each column are called as leading difference. Whatever the first differences that you have obtained, that is called as leading difference. In the formula you are going to see, or you are going to substitute only these values. First difference, that is 37, here it is minus 16, next 1 and 11. Only these values you are going to substitute in the formula. So in the formula one more thing you have to find out, that is value of x. So x is equal to, formula to find out x is equal to the value of x to be interpolated, value of x to be interpolated minus value of x at origin, value of x at origin divided by the difference between two adjoining values of x, two adjoining values of x. So value of x to be interpolated, value of x to be interpolated is 1998. For 1998 we have to estimate the sales. That's why value of x to be interpolated is 1998 minus value of x at the origin, that is beginning value of x. Beginning value of x is 1996 divided by difference between two adjoining values of x. See what is the difference between two adjoining values of x? 2000 minus 1996, it is 4 years. 2004 minus 2000, 4 years. So 4 years difference we can see. That's why divided by 4. So 1998 minus 1996, it is 2 divided by 4 is equal to 0.5. So x is equal to 0.5. Now you need in the formula x, next you need x minus 1, that is 0.5x minus 1 is equal to, it is minus 0.5. Next x minus 2, 0.5, value of x is 0.5 minus 2. When you deduct it will be minus 1.5. Next x minus 3, x minus 3 is equal to 0.5 minus 3 is equal to minus 2. So these are the values of x which we have calculated. Now we will apply the formula and substitute the values. What is the formula of Newton's advancing difference method? Formula is yx is equal to y0 plus x delta 0 raised to 1 plus x into x minus 1 divided by 2 factorial second difference plus x into x minus 1 into x minus 2 divided by 3 factorial third difference plus x into x minus 1 into x minus 2 into x minus 3 divided by 4 factorial into 4th leading difference. Up to 4th leading difference you are going to write because 5 values of y is known. Now substitute the values in this formula. y0, what is the value of y0? See this leading difference table, y0 value is 47. So write it 47 plus x value just now we have calculated, x value is 0.5. X is 0.5. So here it is 0.5 into delta 0 raised to 1. What is the value plus 0.5 into, first we will multiply the signs, minus into minus plus. So 0.5 into 0.5 into 16 divided by 2. 0.5 into 0.5 into 16 divided by 2. The value comes to 2. 0.5 into 0.5 into 16, it is 4. 4 divided by 2 is 2. Plus, next 0. First we will multiply the signs, minus into minus plus. So 0.5 into 0.5 into 1.5 into 1 divided by 6. It is 0.0625. Next we will multiply the signs, plus into minus minus, minus into minus plus. So it is minus into minus plus, plus into minus, again it is minus. So minus 0.5 into 0.5 into 1.5 into 2.5 into 11 divided by 24. The answer comes to 0.4296. So when you, now we are going to add all the positive values and deduct. 47 plus 18.5 plus 2 plus 0.0625 minus 0.4296. Answer comes to 67.1329. So this is the value of y for the year 1998. So we have interpolated value of y for the year 1998. Value of y is 67.1329. Like this you are going to find out the value of y under